Muscles. Muscles can be difficult because there are lots of them and they're layered. Some surface muscles, like this part of the trapezius and this latissimus dorsi, are so thin we don't bother with them, and some buried deep muscles, like this internal oblique, often show on the surface. But let's begin with some general observations. Muscles are thick near the trunk, lean as they move away. On hoofed animals, the distal limbs look like shrink-wrapped bones. Muscles can be simplified by grouping them. These blue groups are extensors. There are several of them with hard-to-remember Latin names, but they make single, easy-to-remember egg shapes. Muscles work in pairs that pull against each other, shown roughly here as complementary colors. We'll name them specifically later. First, let's understand how they work. Muscles can't push. They only pull, like rubber bands. They anchor at the origin and then go into an insertion. Tendon connects muscle to bone. When the muscle fibers go from relaxed to tense, they pull and change the position of a bone. So on this cat, back muscles contract to stretch out the body. That's called extension. Belly muscles contract to scrunch up the body. That's called flexion. You can see how these arm muscles contract and harden. And how these hind leg muscles work in opposition to each other. Muscles seldom connect directly to bones. They turn into tendons that connect to bones. Toes, fingers, claws, and hooves have no muscles. They receive the final tendons. Extensor tendons lift a hoof forward so they don't have to be as strong as flexors. They have it easy compared to flexors. Flexor tendons are stronger, and there are more of them because they propel the animal forward. More about that when we get to limbs. For now, let's remember that anatomical charts are just that. They're maps, not journeys. Our next task is to pull them out of the flatness of the chart into three-dimensional thickness.